Okay, just give me 1 second, I'm gonna erase that. And I'm gonna analyze this problem. It's an optional problem, and it's not easy. A couple things to recommend over here is that I hope you recognize the symbol over here, covered in Math 121. It's the floor function. Before I do that, though, I want to point out I would like to look at y equals the root of 10x, x plus 1, all right? And if you were to graph that, looking at it, starting at 0, you get 0. And it's a root function. It looks sort of like this over here, but it is bounded above by the root of 10, all right? And let me just go through that with you. Limit as x goes to infinity of that function. We're talking about this one over here, by the way. I divide through by x. What do you get? You get 10. On bottom, you'd get 1 plus 1 over x. And if you did that limit, relatively simple, you do get root 10. So it is bounded. So when you're looking at this thing, the bottom line is you're looking for integer values, because that's what the floor is going to be dealing with, is looking at those integer values. So, kind of looking at it, I'm wondering, when does it hit the number 1? When does it hit the number 1? The next thing I'd wonder about, oh, by the way, the root of 10, roughly 3 point something. And then next thing I wonder when it hits the number 2. And then the next thing I might ask is, when does it hit the number 3, all right? Now, it's never going to hit the number 4, so don't worry about that. We got to look at it one step at a time, all right? And someone says, why are you looking at that? The number one reason I'm looking at that, we need to do an integration. And the integration we need to do is we need to do 0 to 10 of this very bizarre looking function, by the way. And the reason we're doing that is we're looking for the average value, which means once we compute this, we're just going to multiply by 1 over, well, it's going to be 10 minus 0. But my trouble right now is, how do I do this, all right? I don't know that guy's antiderivative, and it seems like it might be hard to deal with, all right? So what I'll do is talk about, when it hits certain values, and it's going to jump at those values. So let's just talk about it one step at a time. Yes, I am looking at the floor function, but I'm looking at its argument. And the first question is, when does it hit 0? Well, I do know that. It hits it at 0. But let me go through that with you. So it's right over here. I would square both sides. What would you get? You get 10x over x plus 1 equals 0. Multiply both sides by x plus 1. You get 10x equals x plus 1. I'm sorry, equals 0. What am I saying? Equals 0, x equals 0. Relatively simple. So what do I know? I certainly know that the floor of that, if it's 0, is simply 0, all right? Now, by the way, it's going to maintain that floor until it hits the number 1. So then the next question is, when does it hit the number 1, right? And that's right over here. How would I do that? Square both sides. Relatively simple. Multiply both sides by x plus 1. And what do you get there? Let's see, 9x equals 1. And that would be, let's see, 1/9, right? So I know at 1/9, what happens is the function shoots up. This is not drawn to scale, by the way. It shoots up to 1. Over here, though, it's 0. My next question is, I wonder how long this maintains its value of 1. And it's going to jump when it gets to 2. All right, let's do that. And I write that over here. What do you do? Square both sides. Let's write that down. 10x, x plus 1 equals 4. 10x, that would be 4x plus 4. Let's see, I take 4x from both sides. I get 6x equals 4. Now what happens there? I divide by 6, right? You get 4/6, or 2/3. All right, so when I hit 2/3, again, this is not drawn to scale, all of a sudden the thing jumps to 2. Then I wonder, how long is it going to stay there? And I wonder, what's the next number it's going to hit? Number 3. All right? So let's write that down. How do you do that? Square both sides. And what do you get there? Well, you get 9, and then you get 10x equals 9x plus 9, and then you get x equals 9. So at 9, so then again, it's not drawn to scale. So when you hit the 9, it stops being 2 and it shoots up to 3. But the bottom line is there on after, it's never going to exceed the 3. Never, all right? Never going to exceed that 3. All right, so I got something that looks, fairly easy to do now. And I'm going to get my eraser out and I'm going to try to, emphasize that I've got a bunch of rectangles to compute, all right? A bunch of rectangles. Let me talk about the first rectangle, all right? Let me get my eraser out too and erase this business over here. All right, get a bigger eraser, okay? Get rid of all that stuff on the side. I'm pretty convinced that what I've talked through there, it takes time to think through it. And it took me time to think through it as well. I'm not saying this comes to me immediately. I got to think at the problem, then I write it up. All right, so the first thing I got is, remember I said between 0 and 1/9, the thing at a height of 0. So let's write that down. So the length of this interval is 1/9, and its height is 0. That's my first rectangle, by the way. Let's talk about the next one. The next one, between 2/3 and 1/9, its height is 1. All right? I got to compute that, don't I? And what do you get over there? Let's see. You would get 9, and 6 minus 1 is 5, 5/9. So the first section I got is 0. This section over here I got 5/9. All right, let's go to the next one. The next one, and it's going to go from 1/9, from 2/3 to number 9. Write this down. So from 9 up to, down to 2/3. What's its height going to be? 2. Well, let me do that. And what do you get there? A little more complicated, right? 27. 27 minus 2 is 25. So it's 50/3. I'm going to write that in ninths, though, because I realize the other guys in terms of ninths. I could write this in terms of ninths, too, the first one. Let me do that for you. That would be 0/9. I might have to change that, by the way. That's what the next one's going to be. And this one's going to be 1/59. Again, one upon what we're doing, we're computing the rectangles that this thing generates. We'll look at a better picture later, by the way. All right, so what happens from 9 to 10? All right. Now, someone says, why are you going to 10? That's when my thing stops. All right. So 10 minus 9. What's its height? Its height is 3. All right. That's the last rectangle. And again, I'll give you a better picture of this later. What does that give you? 3, which is going to be 27/9. All right. So first rectangle, 0/9. I got 5/9. Let's see. That's going to be 5/9, and it's 155. Let's see, 62, 72, 82, 182. Whoops, sorry about that. Let me write them down. So what do I have over here? 0/9. Whoops. Get my eraser out again. First rectangle was 0/9. The next rectangle was 5/9. And again, I'll show you a better picture later. 159. And the last one was 27/9. They're ninths. Whoops. And what do you get over there? 155, 155 and 7, 162, 72, 182. All right, so what I'm claiming over here is the integration from 0 to 10 of that crazy looking floor function is 182/9. All right. So, I summarized the rectangle computations here, and I wrote the integration down for you. So someone says, I don't remember what their question was. Was that their question? That was not their question. Their question was the average value. So the average value should be relatively simple to do. What's it going to be? Well, you take this integration, and you're going to multiply it by 1 over 10 minus 0 times that integration, 0 to 10, the floor of the root, and that's going to be 1/10 times 182 over 9. And I got to simplify that. I just don't like the way it looks. And let me see. I'm going to divide through by 2. And let me see if I can do that. I would get 5. And 2 goes in that 90, let's see, 91 times. So you get 91 over 45. Final answer. Let's take a look. And I want to go for the better picture now. I do just want to point out, we did this, and I want to point out the first thing we talked about was the beginning of it. And I want to remind you about that. And this thing took place over here, if you recall, between 0 and 1/9. And the height of that was 0, clearly being indicated over here. This guy's got height of 1. And when did that first occur? Hope you remember. Well, maybe you can't remember. I think it was 2/3 though, right? Yep, 2/3. So remember we said 0, 1/9, and then 2/3. All right? And then we said it maintained a value of 2 until it hit the number 9. Hope you remember that part. What were we doing? We're computing the values of those rectangles. First rectangle 0, then we did this one, then we did this one. And last but not least, what do we have? We had this rectangle compute, and we did that. Where do we do that? Way back over here. And again, they're summarized over here for you as well. All right, we did the computation, got the number. What was our question though? Average value. And that's what we computed. We compute the average value. How do we do that? We had to do the integration first. Thank you.